Alright, constant rate of proportionality, our objective, I will be able to find constant rate of proportionality. What it is, it's two variable quantities that have a constant ratio, so it looks like what we've been doing with constant rate of change. This time you need to notice the linear relationship, which is it means it's proportional when it passes through the origin. Okay, what it means by proportional is if you look at this graph here, the origin is called 0, 0, which is our point right here, so that makes it proportional. So if it goes through 0, 0, it's proportional. Okay, a graph that looks not proportional is this one here. Okay, this one is not proportional because it does not go through the origin. So if you notice the graph on the right, it goes through the point about, 0, 9? Okay, so on the left it's proportional, the right one is not proportional because it does not go through 0, 0. Okay, so what I did was created the table for a proportional graph. This goes back with constant rate of change of what we were doing. Our formula for constant rate of change was k equals y over x. Okay, so our y value was 30 over our x value of 1. So our constant rate of change is 30. So if you made the connection from whenever we learned this last week on Thursday, that it also is the same thing as unit rate. Okay, even if you did the change in y, so we're adding 30 every time. Okay, here we're adding 1. So if you notice it's still the same thing as 30 over 1. So our constant rate of change is 30. Okay, there's two formulas that you'll have to know, I guess, or it's on your formula chart. When it is proportional, your equation will look y equals kx. Okay, if it's not proportional, your equation will be y equals mx plus b. Okay, I'll explain more throughout the week the difference between the two. Okay, so let's look at this first example. Okay. Okay, so our first example we have at the north parking garage, it costs $5 to bring your car into the garage, plus $2 for every hour the car is parked. So first thing we got to do is create our equation. So if it already costs $5 to get in, okay, that's your flat fee. And then it's $2 for every hour you park. So if you notice here, you have y equals 2x plus 5. So if you go back to our first slide, it looks like our formula y equals mx plus b. Okay, so our m is the 2, our b is the 5. So what I forgot to do is on your tables to create the middle part. So you're just going to have to create it yourself. This middle here is just called the process. And it'll help show what you're supposed to do. Okay, so our hours is our x, our charge is our y. So x is our input. So the hours we put in will give us our output, how much we're going to get charged for how long we parked. Okay, also y is your dependent variable, and x is your independent variable. Okay, because y depends on whatever x is to get its answers. So what I'm going to do now is go into the process. Okay, so we're going to plug it into our formula. So we have $2 for every hour. So this time we parked for 0 hours plus the $5 fee to get in. So 2 times 0 we get 0 plus 5 we get 5. We're going to repeat this process. So now we're parked for 1 hour. So 2 times 1 we get 2 plus the $5 to bring your car in. So we get 7. Now we parked for 2 hours. 2 times 2 is 4, plus 5 we get 9. 3 hours, 2 times 3 is 6, plus 5 we get 11. 4 hours, 2 times 4 we get 8, plus 5 is 13. And 5 hours, 2 times 5 we get 10, plus 5 we get our 15. Okay, I created my graph, so now I'm going to go ahead and plot my points. So at 0 hours, we pay $5. At 1 hour, we pay $7. 2 hours, we pay $9. 3 hours, we pay $11. 4 hours is $13. And 5 hours, we pay $15. So I'm going to connect my dots. Okay, so if you notice here, it does not go through the origin 0, 0, so this graph is not proportional. Okay, example 2. Here, this time it just gives us part of a table and our graph. So I came up with our description. My car uses 1 gallon of gas for every 25 miles. Okay, so here we have y equals our miles driven. This is going to be our x divided by the 25 miles for every gallon that's being used. So again, you're going to have to create your middle process part. Okay, so miles driven is our x value. It depends on how many miles we drive will tell us how many gallons we're using, so our y. So I'm going to do the same thing here. I'm going to show my process. So our x is 0 divided by the 25 miles for every gallon. So if we drove 0 miles, we used 0 gallons. Okay, so here, this time we drove 50 miles divided by the 25 miles for every gallon. So 50 divided by 25, we get 2. So I'm going to keep repeating our process. 100 divided by 25 is 4. 150 divided by 25, we get 6. 200 divided by 25, we get 8. 250 divided by 25, we get 10. Okay, so now we're just going to make sure we are correct. So I'm going to check with the graph. So our first point was 0, 0. Okay, 50 is halfway, so 52. 104. Let's see, 156. 200, and then on 8. 250 at 10. And we'll keep going and going. Okay, so here you notice that it does go the origin 0, 0. So this graph here is proportional. Okay, so our next slide will be your you try. Okay, on this one, you will create your description. They give you the table. So create your description, your equation, and your graph. Make sure you have your questions ready for me for class on Monday and for me to answer for you. And we'll work more on this throughout the week.